Hey guys. We're gonna keep on doing it, the programming stuff. Yeah. Tantrums and what is that? Stepper underground. I'm a big stepper. So I was reviewing one of my videos and I realized like all I do all day is just basically just click around. I barely even type anything. And nothing's loading. Look, associate colors. There we go.
Why pay over $2,000 to create an ebook when this $27 AI does it all? Designer.
Hello everybody and welcome to my first YouTube video. Today we're going to be making a moving square in pygame. I'm so excited to get started and let's get right into it. So to get started, we're going to start off by importing pygame.
Oh.
And then we're going to set up the screen and initialize pygame by doing pygame.init. And then we're going to set up the screen, which is screen is equal to pygame.display.setMode. Now in this tuple, we can set up our screen size. I'm going to make mine 500 by 500. Now we can get into our game loop.
That's my fault.
Wait, there's no way. It's playing my freaking openings. Oh my god.
Oh my god, he sounds so different.
Hello everybody and welcome to my first YouTube video. Today we're going to be making a moving square in pygame. I'm so excited to get started and let's get right into it. So to get started, we're going to start off by importing pygame. And then we're going to set up the screen and initialize pygame by doing pygame.init. And then we're going to set up the screen, which is screen is equal to pygame.display.setMode. Now in this tuple, we can set up our screen size. I'm going to make mine 500 by 500. Now we can get into our game loop. So we're going to set running to true, which is our definition of game loop basically. And then we are going to create our game loop. So while running, for event in pygame.event.get, fetching all of the events, if the event.type is equal to pygame.quit, then we want to quit, setting running to false. Now we can basically fill the screen white and then update it and then quit pygame. So to do that, we're going to say screen.fill. The color will be 255, 255, 255, which is white. And then we're going to do pygame.display.flip. Update the display. And then in the end, we're going to quit pygame. So now we can set up the player using
Okay, what does the
Flash.
pygame display flip do? What does pygame, hold up, pygame display flip do? Okay. Do I already have that? No, I don't. Okay. update full.
Method. So to do this, we're going to define it right before.
Dot update. Full. There we go.
We run using class player. Then we're going to give it initial variables, and to actually use them, we're going to define init. Give it a self, x, y, speed, color, and size. Now we're going to make these variables global just inside the method. So to do that, we're going to make a self.x is going to be equal to x, self.y is going to be equal to y, and so on for the rest. The method. And we're going to give it its initial variables. So x is going to be 250, 250 is y.
Oh my god, just make this square.
So for all the other keys. The event.type is equal to pygame.
Oh my god, dude, where does he make the dang square? Where does he get the moving square from? Oh my god!
Now we can basically
Oh my god.
Get tax expertise without hidden fees.
Alpha layer with a transparent background, you'll want to use .convert alpha instead of
Oh yeah, that's what I was. This is the first tutorial I watched on pygame. Wait. Oh, okay.
has a high ref images will be pixel aligned unless you force them to be. The other solution, which is general
What is transform?
transform.scale, but there are also flip, rotate, and many other transforms listed in the documentation. You can play around with those other functions in your own time. Transform.scale takes in a new size and
I'm not unzipping that.
pixels, so if we want to double
Okay. Place image. Okay. Return. See, this is the first video I've ever watched about it. This is how I learned pygame, was the fluffy potato. He's a W. Pygame dot transform dot scale. Oh, no. I want image. I really don't have to do it like this. I don't keep putting potato. Image dot get width. Width, height, image, get width. Width. Dang it. Okay. So that scales the image.
Double the
Okay, this places the image. This scales it, and then this one imports it. So this, basically, I get what it's, so basically, you're loading in the image. Hold on. Loading the image. not length.
The size of our potato, we can access the width and height of the original surface and multiply them by 2 in our scale transform. The returned surface is the surface with the transform applied. In case you didn't catch it, 1 pixel in a source image is 1 pixel in a surface loaded from an image, and therefore 1 pixel on the window, at least until we just scaled it here. Running the code again gives us a potato moving at a reasonable 50 pixels per second over a white background. However, we have black corners on our potato. To fix this, there are a couple solutions. First, if you're using a source image with an alpha layer with a transparent background, you'll want to use .convert alpha instead of .convert to tell pygame that
Imagine being able to build anything just by thinking about it. Meet Base 44.
the faster the game runs, the faster a potato will move. You could
Pygame image dot load image. Dot convert. Define import image alpha image. Did I click something? Oh yeah, I did. I don't know what it was though. Okay, and then I put return. But okay, I'm just gonna put the same thing as this one.
just lock the game to 60 FPS and assume nobody has a high refresh rate monitor or lags to make the potato run faster or slower than 60 pixels per second. But the standard solution is to measure the time between frames, referred to as delta time, and multiply time-dependent math by the duration of the last frame to make things like motion consistent even when frame rates are varying. We'll want to scale the motion of our potato in this case. Clock.tick actually returns the time in milliseconds, which can be used. However, you will likely want to handle edge cases like 0 or cap it, is to measure the time between frames, referred to as delta, motion consistent even by time-dependent math by the duration of the last frame to make things like motion of our potato in this case. Clock.tick actually returns This is what pygame.image.load is for. We just give it a path and it returns a surface made from the file we gave it. Interestingly, surfaces can have different pixel formats associated with them. To use the fastest one for rendering, we should use .convert on the surface when we load it. With of a surface, we'll put the surface given in the box that moves math class down. Pygame to display.flip, which just makes sense whatever if unrendered frame. Code will show a tiny potato fly quickly to the right while creating a trail. There's a couple of things to learn here. First, the game will run as fast as possible unless it's slowed down. To fix this, we can create a time.clock and call clock.tick after rendering with our desired frame rate. 60 FPS is the maximum of your average monitor, but you may want to go faster for some displays. This rendering system also means that the faster the game runs, the faster.
Give me a second. FPS.
Our potato will move. You could just lock the game to 60 FPS and assume nobody has a high refresh rate monitor or lags to make the potato run faster or slower than 60 pixels per second, but the standard solution is to measure the time between frames, referred to as delta time, and multiply time-dependent math by the duration of the last frame to make things like motion consistent even when frame rates are varying. We'll want to scale the motion of our potato in this case. Clock.tick actually returns the time in milliseconds, which can be used. However, you will likely want to handle edge cases like 0 or cap it so it doesn't go too high if there's a stutter. Since clock.tick only has millisecond precision, but again and you'll see that the corners are gone. First, if you're using a source image with an alpha layer with a transparent background, you'll want to use .convert alpha instead of.
There we go. This is what I've been looking for the whole time.
.convert to tell Pygame that the pixel format needs to support pixel level transparency. In our case though, the image actually has black in it instead of a transparent background, so we can just use .setColorKey to tell Pygame which color to ignore when blitting. Run the code again and you'll see that the corners are gone. Before we move on, I should add that there's actually a couple different techniques for rendering pixel art. You can scale all the individual assets and render them like we are now, which gives smoother movement, but not all the images will be pixel aligned unless you force them to be. The other solution, which is generally more performant in busy scenes, is to render at the low resolution your pixel art is suited for and scale it up. In newer versions of Pygame, this can be done using the scaled flag when creating the window, often used alongside the sizable flag. The older method.
Hold up. Okay, look. So, hold up. Loading the image, transforming the image. Sorry. Excuse me. And then placing the image on screen, which is the smoothest and the slowest.
That I use in my other tutorials is to create another surface representing the base resolution of the game. Then render pixel art assets like the potato to that surface without scaling. Finally, you can scale up that intermediate surface before blitting it onto the window surface with a much larger resolution based on the window itself. It's very important to remember that you don't have to just blit images you loaded from a file straight onto the screen. Blank surfaces can be created with pygame.surface, which default to black or fully transparent if you use pygame.srcalpha. You can blit any surface to any other surface, which means you can create a multi-potato surface first before rendering it to the screen. You can also get or set any individual pixel within a surface, but doing so at scale may not be performant. Lots of fancy effects and performance improvements can be achieved through creative uses of surfaces. If you want an interesting example, you can check out my palette swapping video where I do palette swaps using color keys and surface tricks. One more useful feature is the set alpha function that sets the overall transparency of a surface. You could use this to fade out an image by changing the alpha value over time.
You
What
have
in
it
the world did I
listed,
just watch?
you type it in, and then you go digging.
Hold up.
In my Lots of fancy effects and performance improvements can be achieved through creative uses of surfaces. If you want an interesting example, you can check out my palette swapping video where I do palette swaps using color keys and surface tricks. One more useful feature is the set alpha function that sets the overall transparency of a surface. You could use this to fade out an image by changing the alpha value over time. I'd recommend checking out the Surface documentation for a full list of features. All that said, you may want some more tools to your graphical tool belt than just making collages of images you loaded from files. Pygame can also draw various shapes to surfaces with the Draw submodule and create surfaces with rendered text using the Font submodule. For text rendering, it's as simple as creating a font object from a TTF file, system font name, or just letting it use the default, and using the font.render function to turn a string of text into a surface with text on it with the given anti-aliasing and color settings. By default, the surface will have a transparent background even though it's rectangular in shape as all surfaces are, so we can blend it straight onto the screen surface. There are loads of other text-related features if you look through the font document.
That's crazy. Look at. Look. I have to do like 500! Where do you get this from? Uh, uh, I'm gonna fart. Save. Watch later. Wait, it was already in my watch later. Okay, y'all.
As I mentioned,
I am tired. So it's time for me to see. I mean, go, not see. See you guys later. I barely wrote anything, to be honest. Just wrote a couple of comments. Yeah. Clean it up a little. Okay, well, bye, y'all. See y'all in the next video.